Hello students! I get to show you one of my favorite functions in Python today. Maybe not base Python, but it is in the functools library. And it's not too hard to grab something from there. The function's called reduce. So let's grab it from functools, import reduce. Now this function exists in many different languages. It's often referred to as fold in some other programming languages. Python chooses to call it reduce. Let's talk about what it does. We're going to give it a function that takes two things, two arguments, and an iterable. What reduce does, it grabs the first two things from the iterable, applies the function, gets an output. Then it takes that output and the next thing in the iterable, applies the function. Then it takes that new output and the next thing in the iterable, applies the function. So it does this over and over and over again, repeating as we go. So you can do some very nice repeated processes using this. What are some examples that we can use? Let's think about the triangular numbers. How do those work? Well, that's the sum of 1 through n. So let's try to do this using reduce. So let's define triangular, n. And what I want it to do is I want it to return, okay, well we're going to reduce. Now in order to reduce, what we need is we need a function that adds two things, and we need an iterable. So what our iterable will be is we're gonna just give it the range from 1 to n plus 1. So we're going to have the numbers 1 through n. So the first time it's going to grab 1 and 2, then it's going to take that output and grab it with 3, then it's going to take that output and grab it with 4, and so on. Now what do I need to put here? Before the iterable, that's the function. So I need a function that takes in two things and returns an output. And I want it to add these things two at a time. Well, I could try sum, but unfortunately that's not going to work. Let's see what happens if I try, say, getting triangular 3. That would be 1 plus 2 plus 3. I get an error. It apparently looks like it's trying to grab elements out of an integer. Well, what could be going on? Well, let's think about what reduce does. It's going to take the first two elements and it's going to apply the function. So the first thing it's doing here is it's taking sum of 1, 2. And what's this doing? Well, remember, it's going to treat sum works on an iterable, so it's looking at 1 as if it's an iterable and trying to take things out of 1. Okay, so what could I do to fix this? Well, I need to give it a function that takes in two elements. I want it to take in two elements and add them. Well, one thing I could do is I could write my own add to function. And this will work perfectly well. I can now fix this by placing add to here. And you'll see that if I take, say, triangular 3, which should be 6, I get 6 just fine. Or triangular 4, I get 10. Okay, nice and all. But let's practice this with just lambda. So we maybe didn't have to write those two other lines up here. We could have done this all in a single line. Just one line for naming the function and one line here. So how would we do this with lambda? Well, we need to make a function that takes in two things. So I need two arguments. And it returns their sum, x plus y. Boom. So triangular 3. And this works just as well. Triangular 4. Okay, so we've done the triangular numbers, and what's a lot like them? Well, the factorials. If I were to take this sum here and change it to times, right, instead of plus, I would get n factorial. So let's write a function that returns factorial. Now, of course, we could always grab one from the math library or something like that, and we know how to do factorial recursively, but let's do it this way. This has some advantages. Okay, so what do I want now? Actually, why bother rewriting this? It's going to be the same exact thing with a single character, one character change. Boom, I now have, no, that was not an impressive boom. Boom, now I have my factorial function. So let's try factorial 4. I should get 4 times 3 times 2 times 1, and that's exactly what I get. What's happening here when I type factorial 4? Well, it's going into this range, grabbing the first two things, 1 and 2, multiplying them. I got 2 as my output. Now it grabs the next thing, 3, multiplies the 2 and the 3. I got my output, 6. Now it grabs the next thing, 4, takes the 6 and the 4, combines them using my lambda function, and gives us 4 factorial. Okay. One thing that we sometimes want to do in coding is to flatten out a list of lists. So what do I mean by that? I mean, let's say I have 1, 2, 4, 6, 7, 8, and 9. Okay? And what I really want here is I want it to take the elements in those lists, in the little lists on the inside, and I just want to make one list. So what I want is 1, 2, 4, 6, 7, 8, 9. Okay. So how can I do that? Well, one thing I could do is I could take the individual things here, 1, 2 plus 4 plus 6, 7, 8, and plus 9. And that'll do what I want. So this is kind of a little like what we did with factorial, when we have a bunch of things in order that I need to add up. Like I could take the 1, 2, and the 4, add them up, get 1, 2, 4. Then take 1, 2, 4, and 6, 7, 8, add them up and get 1, 2, 4, 6, 7, 8. And then I could take 1, 2, 4, 6, 7, 8, and 9 and add them up. So I could do this step by step. That's how reduce works. So let me define a flatten to flatten a list of lists. I'll call it LL for list of lists. Why not? Okay. So what I want it to return, and I want it to reduce, and what I want it to do is I want it to basically just add the things on the inside one at a time. That was lazy. I could have easily typed that. Okay, and what do I give it? I give it my list of lists. So and it's doing exactly what I said. First it's adding the 1, 2, and the 4, setting that aside, grabbing the 6, 7, 8, then combining, setting that aside, grabbing the 9, and combining. I should let you know that this isn't the only way to do this. If you want another way, flatten 2 for a list of lists, we can actually do this with a comprehension, a list comprehension, because it's got to be a list. So how could we do that? Well, we want the things on the inside, right? So let's take the I for I in inside list for inside list in the big list. Unfortunately, this is not going to work. And let's see why. And let's give it this input right here, and there we go. And I get an error like I said we would. And that's because it hits inside list before it's defined. So the only thing we need to do in order to fix this is change the order. I need to grab the inside list first so I have an inside list at hand when I'm grabbing from it. So now let's try that. And now it works just fine. So that's another way that we could flatten. So we didn't need reduce, and quite often you're not going to necessarily need it, but it can come in very handy in many different situations. So that's your introduction to reduce.